Good evening, everyone. Welcome to Tuition Center. So today we'll continue in chemical bonding, where we'll be looking at convalent bonding. So convalent bonding, this is a type of bonding that occurs among non-metals. So for this one, it doesn't occur between metals and non-metals. This one just occurs among non-metals. Then for this one, unlike ionic bonding, where only one gives electrons to the other, for this one electrons have to be shared, so it involves the sharing of electrons. So that's what covalent bonding is. So the things you need to know is that it occurs among non-metals, and this one doesn't involve the giving away of electrons, but it involves the sharing, where if at all you have got two atoms that are joined covalently together, if let's say this is atom N and this is atom M, so for covalent bonding, this atom M is going to give electrons, and also this atom N is also going to give electrons. So they will give electrons so that they should share. So this one, it's a double way thing, it's not a one way thing. So that's what covalent bonding is. So you need to also know that this same covalent bonding is also known as molecular bonding. So you can either be told to define what molecular bonding is, so the definition is just the same. So covalent bonding is also known as molecular bonding. So remember to say, I'd said that it involves the sharing of electrons. So those number of electrons that are being shared by the atoms are what is known as convalency. So this simply is the number of electrons that are shared between electrons. So if maybe two atoms are sharing 2 electrons each, the convalence of those 2 atoms is 2. So it's simply the number of atoms that are being shared. So another thing that you need to know under this covalent bonding is that since it involves non-metals, these bonds can be in type. So they can be either double bonds. So I'll just use 2 double bonds, single bonds, which is 1, single bonds. And then for double bonds, they are represented with 2 lines like that. For single bonds, like that. And then they can also be triple bonds. They go on just like that. So these bonds for non-metals can be double bonds. So let me give some of a few examples of covalent bonds of non-metals. So I'll start with the ones which have got single bonds. For example, let's do water. So water, the chemical formula for water is H2O. And then, as you can see here, hydrogen here is a gas and oxygen is a gas as well. So when these two bonds, they won't form an ionic bond, but they'll form a covalent bond because both of these are gases. And then, just the same as ionic bonding, any type of bonding, covalent and ionic bonding, only the valence electrons are involved in the bonding, not the inner electrons. So only the ones in the outermost shell. So we have H2O. So for this illustration, I'll just consider the valence electron. So hydrogen has got 1 valence electron, so I'll use a cross to represent for hydrogen. And then for oxygen is found in group 6, therefore it has got 6 valency electrons, so I'll use dots. So 1 2 3 4 5 6. And then you need to know that for hydrogen to be stable, it needs to have 2 electrons in its outermost shell. Then for oxygen to be stable, it needs to have 8. So since it has got 6, and when you have got 1 hydrogen atom, when it gives 1 here, and when this one also gives 1, the hydrogen quite right here is going to have 2 electrons. But for oxygen, since we only have 1 hydrogen, when it gives 1, oxygen will have 7 in its outermost shell. Therefore, we need to have 2 hydrogen atoms of oxygen, so that if of hydrogen, sorry, so that even oxygen can be stable. So therefore the covalent bond is going to be, so we're going to put oxygen in the center. So when you're drawing these diagrams, when it depends with the question. So in the center of the diagram, you need to put the symbol of the element. So in the sides, we're going to put the two hydrogen atoms and H there. H, since we've got two there, then hydrogen is going to give one electron and oxygen is also going to give one. Then even here to give one and oxygen will give one. So since oxygen gave two electrons, one to each hydrogen atom, we're going to remain with 4. 1, 2, 3, 4. So when you count, hydrogen will now have 1, 2. So hydrogen is stable. Even this one is stable. And then for oxygen, when you count, it's going to have 8. 1, 2, 3, 4, 5, 6, 7, 8. Therefore, this is the covalent bond of water. So when you look at here, since they are only, hydrogen gave one atom and hydrogen gave one electron and oxygen gave one electron, these are sharing a single bond. So when you have been told maybe to show to show it using using the maybe single bonds like that, these are bonding like that. So this is representing a single bond because this one gave one electron and the other one gave one electron. So let's go to the last one, which is the double bond, and then we'll go to the characteristics of these covalent bonds. So an example of a molecule that has got a double bond is carbon dioxide. So carbon dioxide is found in group 4. Therefore, for it to be stable, it needs 4 electrons for it to be stable. Then oxygen is in group 2. I already explained the number of electrons it will have. So I'll also show you just the outer shells. So for carbon, it's represented by C there. So I'll use crosses for carbon like that. It has got 4 outermost electrons, and then for oxygen, it has got 6. So this oxygen will give away 2 electrons to the carbon dioxide. Then this same carbon dioxide will give away 2 electrons, and then since there are 2 oxygen, so each oxygen is going to give 2, and then even the carbon dioxide will give 2. So this is how the bond for carbon dioxide is going to look like. So we're going to put our carbon there in the center and our oxygen on the side, and the oxygen there. So we're told, I said oxygen will give 2. So I've got 2 electrons from oxygen, the dots, and the crosses from hydrogen, from carbon dioxide, from carbon. Then even this other oxygen will give 2. And then since this oxygen has given 2, and then oxygen has got 6 outermost electrons. Since it has given 2, it remain with 4. So 1, 2, 3, 4. Even this one, 1, 2, 3, 4. So when you count the number of electrons that carbon dioxide has, you see it has got 8. 1, 2, 3, 4. 1, 2, 3, 4, which is 8. Even oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Even that one. So the key thing that you need to know is that if this element gives 1 electron, even the other one needs to give 1 electron. So for this one, it's equal. What you give me is what I give you. That's how covalent bonding is like. So let me quickly rush to the characteristics of covalent bonding. So just like ionic bonding, it has got its own characteristics. Covalent bonding has got its characteristics that make it to be known as covalent bonding. So one of them is that it's made up of molecules. So molecules are made because of this type of bonding. So it's made up of molecules. And then it has got a low melting point. So let me just represent it as MP. Low melting point and low boiling point. So for these ones, their melting points and boiling points are very, very low, unlike ionic bonding where they are high. And then the reason to why these have got a low melting point is because the forces that are holding the bonds together, the forces that hold the bonds together of hydrogen and oxygen when they bond, those forces that are holding them together are weak. They're not as strong as in ionic bonding. That's the reason to why these have got low melting points and boiling points. So you can be asked to state a reason to why these have got low melting points and boiling points, because the forces that are or intermolecular forces holding the bonds together are weak, and then they are insoluble in water. They're insoluble in water, H2O. So when you put them in water, they can't dissolve in water. They are insoluble in water because they can't be polarized by water. Then they do not conduct electricity. So these are bad conductors of electricity. They don't conduct electricity. So whether you put them in molten state, in liquid state, in solid state, in any state, these covalent bonds do not conduct electricity. And then the last one is that they are volatile. So these are volatile. So this is the end of our lesson for today. So so you can just peruse through, and when you look at the same concepts that I've explained in here are the same concepts that are asked in the examination. So you can even go through, maybe in a past paper, you see if you'll be able to answer from these same concepts that I've explained. The next time we'll be back, we'll look at an examination question. So for now, it is goodbye. Have a wonderful night, and don't forget to join our tuitions, because for now it is free, while you have access to everything for free. So for now, it is good night. Have a wonderful night. Thank you.